Okay, in section 2.2, we're solving linear equations in one variable. So the nice thing about solving equations is that it follows exactly the composition of mathematics. So in composition, we know that equations are made up of expressions, two expressions on one on each side. Expressions are made up of terms, and terms are made up of factors. When we're solving an equation and we want to accomplish our goal, we are going to take along the way, basically manipulate each of the components of composition. So the first thing we're going to do is look at each expression. Now, what can we do with expressions? We're going to simplify. Then, once the expressions on each side are simplified, our next goal is to isolate the variable term. Let's get our terms in a position where we want them. And then finally, factors. We'll isolate the variable factor by attaching reciprocal factors. So solving a linear equation basically follows the composition of mathematics. And that's why we do the things in order, because it's the structure of mathematics. It's the way mathematics is written. So let's give an example. And again, this is all goal oriented. If you think all of our um, directions are goal oriented, so we have a goal in mind and we use our properties to accomplish that goal. So let's look at the first example. Solve the following linear equation. And again, we know our goal when we're solving. Our goal to solving is to eventually get x by itself on one side. Now it just so happens that x is starting out on the left side, so I naturally wrote it on the left. When I go back, now I can start looking at the composition and realizing that on the left side, I have two terms. So I have this extra term that I want to get rid of. And I also have this 3 times x. I have a factor of 3 that I need to get rid of. I have this extra factor of 3. So what do I do first? And again, I need to follow composition in the order that it's defined. So I have an expression. So the first thing I'm going to do is get rid of the term. Isolate the variable term on one side. So 3x is our variable term. I want to get 3x by itself on one side. What do I need to do to accomplish that? I need to get rid of the negative 5. So I'll attach a positive 5 to both sides. So I get 3x equals 12. So we isolated the variable term first. And now we're ready to isolate the variable factor. So the next goal, to get x by itself, I see there's an extra factor of 3. So I want to attach a factor of 3 in the denominator to cancel. So if I attach a factor of 3 on both sides, 12 divided by 3 is 4. So now I accomplished the last goal, was be to isolate the variable factor. So again, why we do these things in order is because of composition. Expressions are broken up into terms. Terms are broken up into factors. So when we manipulate an expression, we're going to start with the terms and then with the factor. So what if our expressions have variables on each side? Well, the manipulation is still the same. Our goal, eventually, our overall goal is to get x by itself. But since my expression on the left and the expression on the right both have a variable term, then the first thing I want to do, the first goal, is to isolate the variable term on one side. So we could do that if we attach a negative 4x to both sides. Again, it doesn't matter if the term is a number or a variable expression. I'm attaching it to both sides of my equation, so the equation remains balanced. So what happens is on the left side, 6x and negative 4x is 2x. I still have the plus 2, but on the right side, my variable term is zeroed. They're 0 pairs. So now to isolate the 2x, I'm going to attach a negative 2 to both sides, and I get 2x equals negative 12. So I accomplished my goal by manipulating terms, right? Manipulate terms in the expressions. So once I have my variable term isolated, I got my goal, so now I can look at the factors. So again, this has an extra factor of 2, so I want to cancel that. So as long as I attach the factor of 2 on both sides, I get x equals negative 6, right? So negative 12 divided by 2 would give me negative 6. Okay? So again, just following the goals, isolate the variable term on one side. You can attach any terms you want on both sides, and then isolate the variable factor by attaching the same factor on both sides. So what if my expressions are basically complicated, right? So instead of thinking about the terms and the factors and all that kind of stuff, the first thing is an initial goal, which is to simplify each expression, right? And when we simplify each expression, we are going to distribute and combine like terms. So on the left side, I see I have two terms, 7 and negative 2. I'm going to distribute the negative 2 to both terms in our parentheses. I'm going to distribute, and that's going to give me a negative 10a, and negative 2 times negative 3 is positive 6. So I have a 7, negative 10a, and 6. So that gives me a negative 10a plus 13. So the left side is simplified. So expanding and then collect like terms. And I want to do the same on the right. So the right side, again, I have a new term here. So I have a 4a. And here I'm going to be distributing a factor of negative 1 to create, or just to create my two terms. So negative 1 times 7 is negative 7. Negative 1 times negative 3a is a positive 3a. So when I combine my terms here, I get 7a and a negative 7. So now I accomplished my goal. So I'm off to the next piece, which is variable terms. So now the next goal is to isolate the variable terms on one side. So here I'm going to do this since I'm just manipulating terms, say I add 10a to both sides. No, the reason is because I could isolate the variable terms on the right side because it doesn't matter what side you isolate them on. So I'd end up with a 17a on the right. The negative 10a and the positive 10a are 0 pairs. They're gone on the left. But you notice the negative 7 is also on the right side of my equation. So in the same time, I could isolate or get rid of that term by attaching a positive 7 to both sides. And all I need is a reminder of what I'm doing. But if I do that, I will zero out the negative 7 from the right, leaving just the 17a. And on the left side would become 20. So again, I could do that term. I can do as many terms as I want as long as I just note what I'm doing to both sides, um, making sure I'm attaching the same terms to both sides. Now finally, the last is the variable factor. Isolate the variable factor. And for this one, I have an extra factor of 17. If I create, or if I attach a factor of 17 at the denominator to cancel, then I get my answer. 20/17 is equal to A. All right, so again, you can try the equations on page 62, but the main idea here, if we go back, is that our goals to solving an equation algebraically are in the same order as the composition of algebra, composition of mathematics. So expressions, we want to manipulate those first by simplifying. Then we want to take and isolate the variable terms. The terms are next. Expressions are split up into terms, and then terms are split up in factors. The last thing we will do is worry about variable factors.